Hello and welcome to this video. In this video, we want to finish up this series on videos and displaying videos using an FPGA board. Specifically, I am making use of the DE10-Lite board made by Terasic, making use of an Intel Max 10 chip. So while this video is geared towards that board, the VHDL code will really be the same, whatever board it is you're using. Well, it will largely be the same, whatever the board it is you're using. The slight differences might come in when we talk about the IP catalog, which I'll deal with in just a bit. We'll talk about the IP catalog, and I think just about the IP catalog, and then talking about the frequency of the clock signal coming into your board or coming into your design. So I've taken the liberty to start out the project. I've created an entity, just simply called it video 1. So the name of the top level entity is video 1. You see that here as well. Top level entity is video 1. I have two inputs: the clock, a 50 megahertz clock that is going to come from the board. BTN1, I want to use this so that I can display two possible things on the screen by flipping one of the switches. So I call it BTN1 for lack of a better, I couldn't think of any other name to use. My H-sync and my V-sync that we talked about, R, G, and B will take red, green, and blue. Now, one thing I should mention is that my red, green, and blue are 4 bits. Each one of them it has 4 bits. Okay, each one of them is a standard logic vector with 4 bits. And remember, we talked about images being 24-bit images. Well, the DE10-Lite board is only capable of working with 12-bit images, so displaying 12-bit images. So each image will use 4 bits to represent red, 4 bits for green, and 4 bits for blue. That gives us 12 bits. Secondly, the other thing I didn't mention in the last video is that I talked about sending, if you had, say, an 8-bit data, you want to send over red, 8-bit data, you send over green, 8-bit data, you send over blue. More accurately, you send analog signals. If you're using a VGA cable, the typical VGA cable, you make use of, it actually makes you send analog signals from your end to the display. It does not take digital signals. So you don't send ones and zeros. So what you have is you have a digital to analog converter that converts your 8-bit value to an analog signal. So each pixel gets 1 clock pulse, and with that 1 clock pulse, it gets 1 analog value for red, 1 for green, 1 for blue. Those 3 come in parallel. Remember, you had 1 line for red, 1 line for green, 1 line for blue. So those 3 come in parallel. So with 1 clock pulse, you get red, green, and blue. You have analog values. So you don't really need the 8 bits in all. All you need is the analog value. And that is one reason why, whether we're using 4 bits to program the whether we're using 12 bits to represent each image, or use 8 bits to represent each image, or we use 24 bits to represent each image, the display is agnostic to that. The display simply receives an analog signal, and whatever analog signal it receives for red, it knows the amount of red to do. Whatever amount of analog it receives for green, whatever amount of analog it receives for blue, it just displays that amount, and that is that. Now, the display resolution will not look as great if you had an 8-bit image compared to a 24-bit image, but despite that, the display really is agnostic to how many bits you're encoding in your digital system, because the display is analog. Okay, so displays are actually analog in nature. So your R, G, and B are standard logic vector 3 down to 0. Then I'm going to have a sync clock, a signal that I will actually be using to time what I'm sending onto to send data to the display. I call that a sync clock. Now, if you remember the standards we have for all the standards you have out there, I don't think there's any of them that uses 50 megahertz. 50 megahertz is what we have on the board, so we're going to have to convert that 50 megahertz to a different frequency, and that frequency is what we're going to use. I went ahead to write out the parameters for a 640 by 480 display. This is a VGA display. So you have your front porch. This stands for horizontal front porch, horizontal sync pulse, horizontal back porch, and horizontal video area. Okay, so this is the active video area for the horizontal. For vertical front porch, vertical sync pulse, vertical back porch, vertical viewing area, that's what you have over here. So these are the parameters that we had in our Okay, so maybe I should just pull that up so that we can see this up. So the last video we had, these are the parameters we had for your VGA signal and for a VGA signal. So you have your front pulse, your sync pulse, back pulse, active video signal. So these 4 parameters are what you see showing up, or I should say these 8 parameters are what you see showing up there. I set them as constants. I've set them as constants here so that I can just simply mention this name and I know what exactly it is I'm talking about. I've included 480p here because you might want to copy this and maybe have another one for a 720p display, for a 1080p display. You may want to do that if you wanted. Now, having multiple displays that way, you could have, say, other switches that you use to determine which of the resolutions you're going to display things at. For this video, I'll keep things simple. I'll just have one display. So I'll still keep this nomenclature so that, well, and I'll make this, by the way, this project will be made available on my GitHub page once we're done with it. So we have those constants I selected. Then I said we're going to have 2 counters, one for your horizontal position and one for the vertical position. So those are the values I have over here. Now, the horizontal position will count from 0 to 800, vertical position will count from 0 to 525, but whatever. I tried to make them go for a range, make them 10 and 11 bits. 11-bit counters. Okay, so I tried to make them 11-bit counters. We have this. So if we decide to take it up to 1080p resolution, this should still work. Now to write the code, I intend to write this code using 2 processes. One will be to determine the RG and B for each RGP. This should be RGB. The red, the green, and the blue for each of the pixels you have out there. So in this process, what I'm going to do is check pixel by pixel and determine, okay, this pixel should be red, this pixel should be black, this pixel should be green, this one should be black, this one should be this. So whatever colors I want those pixels to be, I'm going to determine them within this process. In the second process, I'll go ahead and actually do the displaying. And so we'll see how that goes in a bit. This is where my sync pulses will be generated. And remember that without the sync pulses, things can actually get displayed. Here, I'm just going to determine what should the RG and B be for every value of H pose and V pose. That is all I'm doing here. Determine the value of RG and B for each H pose and each V pose. So if you want, I'm kind of creating a matrix of frames, what each frame should be. So let's come in here. Well, firstly, for the fun of it, I'll create a variable called hpix. And this for horizontal pixels and vertical pixels. Now, the reason why I'm creating this, do we need to create this? The answer is no. Integer range 0, 0, 0 to 247. And I'll initialize this to 0. Now, do we need to create this? The answer is no, but I want these values to hold the actual pixel value. So remember what we said in the last video where, let me see, pixel 0 is H position minus 160. How do we get 160? Front pulse plus sync pulse plus back pulse gives us 160. So present H position minus 160 will give me my horizontal pixel at any point in time. So I'll just keep track of my H pixel and my V pix, and that should be good. So we could go ahead and just start with that. So my H pix at any point in time will be equal to, okay, so I'm seeing that I could have one possible problem. The fact that this is a range from 0 to 2047, whereas my H pix will be negative at some points in time. Now, I typically never use this in my code. And the reason is that I already have my H pose and my V pose, so I just don't create another set of parameters. But if you want to create it, you could create it. So let me say this starts from minus 200. And if I do run into some snag here, then I'll probably just take this off, since this is really the first time I'll be writing using H pix and V pix. Okay, so H pix will be equal to H position minus, now I could write 160, but what's the point in writing 160 when we actually have HFP 480p? I mean, since we have those parameters, this way we know we are definitely not making a mistake. And if we come and later on decide to change these values, we can as well, it will just simply update them straight up. Now, maybe I should take off this 480p so it gives me fewer things to type, but I'll just leave them in there since they are in there already. 480p plus H back porch 480p. So I'm going to subtract that from H pose. And once I subtract that from H pose, that should give me, so it starts from 0, and that's, yeah, so that should give me my value of my H peaks. Then I'll just duplicate this line and change this to V. So V pose minus VFP, V sync pulse, and V back porch. Good. So that is specified. Now I can use an if statement to determine some things, or if I want, I could use a case statement. So let me use a case statement. Case button 1 is when. So I'm now checking button 1. Button 1 can either be 0 or it can be 1. So when it is 0 and then when it is 1, we're going to have that. Then I'm going to have a when others, and I will default this, or in fact, let's do this way. I'm going to make it when 0 or when others, so that I don't have to bring in another case for when others. It's always a good idea to have when others in case, standard logic is not just 0 and 1. Standard logic, you also have high impedance and you have several other things in there. So in the case when button 1 is 0, what do we want to happen? Okay, so what do we want to happen? So what I'm going to do is I'm just going to draw two different shapes on the screen. So I'm going to use Microsoft Excel because this could make things rather relatively easy for me. So let's say this is our 480. Let's go back to the beginning. And okay, so let's say this is 480. Okay, so I think let's take one more. Yeah. So let's say this is 480 different pixels. 640 different pixels in one row. And let's say the height is 480 pixels. We can decide to draw, say, a box within this region. Okay, where do we want the box to be? Let's say we want the box to start from pixel 50 to pixel 100 on the horizontal line and on the vertical line. So let's say we want to start from, say, 50 and end at 100. And let's say in terms of vertical, okay, in the verticals, we wanted to start from, say, pixel 120 and end at pixel 300. Okay, so I've just picked some values there. If that is the case, then whenever it is within this region, we want it to be a specific color. What color do we want it to be? Well, let's see. Let's see if we can use more colors. Let's see if we can use Excel. I want to see if, okay, yeah, so it does give me the values. So I can pick any of these values here, whichever color I feel like is good. Let's see, let's just pick something. I'm going to pick this. Notice the R, G, and B values. Let's say I pick this color. Okay, so whatever this color is, that's 49, 169, and 106. Now, I should mention that this is the decimal value, decimal value, decimal value. This is the hexadecimal value. So I could pick this value, except that this value is a hexadecimal value, and this is a 24-bit image, 24-bit color. So I probably don't want to pick this exactly as is. Rather, I'm going to have to divide it by. I'm going to have to divide it by 4, so that I have a 4-bit. That's a 6. So red will be 4 bits, green will be 4 bits, and blue will be 4 bits. So let me just paste what I just put down here. I'll use this later on. Okay, so let's go ahead and say that if, so we're going to check whether my H peaks is greater than, or whether I want to be greater than or equal to the start point where I want it to be. In fact, let's just go ahead and, so let's call this H start 1. Now, it's a good idea to just have things out there so that I can make this a constant, actually, since I'm not going to change this value during my execution. So it's an integer, and I'm going to give it a fixed value of 50. That's what I want the H start 1 to be. I'm calling it start 1 because I'm going to have a start 2 later on. Now, constant H end 1. I'm going to make that an integer and have a value of 100. Good. Now I'm going to duplicate this and say that start 2 will be 150 and end 2 will end at 250. Then I'm going to do the same thing for my verticals. I also need this for verticals. So I'm going to copy all of this, or just say Control D. Good, so that just duplicates it. I'm going to change this to my V, 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 V. What values did we set? We set, I'll just keep that open, 120, 300 for the start 1. So this was 120, 300. And I'll keep this as 300 and make the, oh, sorry, end 1 should be 300. I'll keep end 2 at 300 and make start 2, say 250. Okay, so just in case you haven't guessed it, start 1 and end 1 will be for when the button is in position 1. Start 2 and end 2 is when when the button is in the second position. So when the button is 0, I use start 1 and start and end 1. So if hpix is greater than or equal to h start 1, and note that this is going to have to be an and, okay, because you're going to check different things. If it is between start 1 and end 1, then it means hpix is greater than or equal to h start 1, and hpix is less than or equal to h end 1, and vpix is greater than or equal to v start 1, and vpix is less than or equal to v end 1. Okay, so bear in mind these 4 conditions must all be true. If all that is true, then, so I'm just going to put my end if here so I don't forget it. So if all that is true, then I want my red to be equal to so I want to do 31 divided by 4 in hex. Oh, so I'm not going to do this calculation. So my apologies. What we'll end up with will not look exactly like this. I'm just going to pick some values and wing it. So let's say this will be 4. Okay, so I want this to be in hexadecimal. So it could be 4. Sorry, this should be that way, I believe. I actually don't remember whether this 0 should be here. If it throws an error, I'll take off this 0. So that will be 4, and then my green will be, let's make it a much larger number. I'll make this, say, A, and then my blue will be, also I'll make this a large number. Let's just make this A as well. Okay, so this is that. Else, if that is not so, if it is not within that boundary, then I'm going to make my R, G, and B. Oh, now. R, G, and B are outputs, are signals. So this is not how we do signal assignments. This is how we do signal assignments in VHDL. My R with that, 0x 0. My blue, green will also be 0. In fact, I'm just going to make this others 0. I don't need to draw it, write it out this way, but I'm just going to write it out this way. Okay, so I think this is about it for this case. Now, when others, I'm going to now not use start 1, rather I'm going to use start 2. So when others, now I'm going to be checking against start 2 and end 2 and start 2 and end 2. So that's about it for this process. I have determined what the pixels will be at every case. So they are either always black or they are whatever this color is whenever I'm within this region. So that means within this, so what I have effectively done, if I come back to this Excel screen, what I have effectively done is to say that this whole region here will be painted that color, and every other region will, so this region will be painted that color, and every other region will be black. Okay, so everywhere else, ideally I should paint them black. So that is what the code is telling it to do. Good, so we have determined that. Now let's come down to this place, which I said is the process for actually displaying things. Because so far, we have not displayed anything on the screen. We've just determined what the pixels should be. So now I'm going to come in here within this process. And I'm going to be checking my H position in this case. Now, all I want to do really is I want to make sure that things happen on the rising edge. Okay, so I want to make sure things happen on the rising edge. That is why this is synced to sync clock. And in fact, for me to just pause at this point, there's something I should have probably done a little earlier. And that is, I want to generate my sync clock. This sync clock I need here. I'm going to use an IP catalog in this case, not because I need it for this particular scenario where I need 25.175 megahertz, but because, well, for 25.175, if I want to use 25 megahertz, I don't need an IP catalog. But because you might want to use a different display with 65 megahertz, with 98 megahertz, then it's a good idea to come to the IP catalog. The IP catalog gives you a library of entities, I'll call them entities, that Intel have gone ahead to create for us, that you can just make use of for several things. You might want to do some arithmetics. So to do some arithmetic, for instance, finding the square root of something, to do division, to do addition, literally you could make use of these IPs, okay? Make use of these entities that have been created already by Quartz. There are things for handling memory. Let me see. Things for handling on-chip memory, for instance, RAM, ROM, FIFO, first in, first out memory. To handle memory, there are entities for handling that. For configuration, for programming, what we're interested in this case is PLL. So I'm going to take Alt PLL and double click on that. It will ask me what language, VHDL, what name do I want to call this entity, this IP that it is creating for me. I'm going to say, I'm going to call this CLK, let me call this my clock, my CLK, my underscore CLK. The name just matters when we are calling it as a component, okay? So I need to give it that. Then it brings up this environment where I can configure the clock. Now, you can take your time to go through these. I won't go through all the nitty-gritty of it. However, I'll just go through the settings I need to go through. So it's asking here, what's the frequency of the input clock? Frequency of my input clock is 50 megahertz. That is what our board has. So 50 megahertz. I can also go to the next. Do I want an asynchronous reset? No, I don't need an asynchronous reset. Do I need a locked output? No, I don't need a locked output. A PLL is a phase locked loop circuit. It can be used for multiplying or dividing frequencies, but it also helps to keep two different signals in phase to make sure that they stay in phase. I'll go next. Bandwidth, I'll go next. Clock switchover, I'll go next. PLL reconfiguration, I'll go next. Then it's now asking me how many output clocks do I want. I can have up to 5 different output clocks with just one input clock. So say, for instance, you had 5 different resolutions you want to support. You could just specify the frequency for each one of them as an output clock. In our case, I'm just interested in clock 0. So clock 0, use this clock. Clock 1, use this clock is not checked, so I'm not using any other clock. If I checked it, now you see this signal, the diagram here changes, but I'm not going to use any other clock other than C0. I can specify what I want to multiply by, what I want to divide by, or I could just specify the frequency I want the output to be. So I'm interested in having an output frequency of, what's it? 25 points, I believe it's 0.175, 25.175 megahertz. That's what I want to have as my output clock. Now this actually multiplies by 74 and divides by 147. Notice that your output clock is not exactly what we want. Now just give me a moment to confirm that the frequency is correct, 25.175, that's correct. So we are multiplying by 74 and divided by 147. We don't get exactly the frequency we want, but this is the best it can do for us. Well, that's fine. Next. I don't have any other clock that I'm generating. EDA, not interested. Next. Summary, what do I want it to create for me? Well, I could ask for a component declaration. I wouldn't bother to ask for that. This too will by default be generated. So with the VHD file it creates, I can create my component, so I don't need it to create a component for me here. Finish. It does it asks you, do you want to add this to the project? Yes, please, go ahead and add this to the project. So it does its magic, and once it is done, I'll come to my project navigator, and I want to show files instead. When I check files, now you see my clock.qip, and you see my clock.vhd. Okay, so this is the VHDL file it generated. It won't give you the full architecture. A lot of things happen under the hood, but then yeah, it gives us enough that we need. So to create an entity, to create a component for this, all I really need is this. Now I won't bother creating a component for this because it is a lot easier Well, I'm going to need a port mapping. So let's do a port mapping. Nope. Where should I be doing this? Before the process. So, or anywhere outside the process. So I'm going to do my port mapping here. I'm going to say create sync clock. That's the name of the map. Or let me say sync clock map. Sync clock map. And I can simply use work dot, the name of the component is my CLK. Work dot my CLK. And let's see, what's the name of the architecture? SYN, SYN is the name of the architecture. SYN. So that's the architecture I want to use, port map. And I want to now map things to it. It has one input and one output. The name of the input is in CLK0, output is C0. So in CLK0 is going to be mapped to CLK50, and C0, which is the output, is going to be mapped to my clock, which is called sync CLK. That's it for this port mapping, and we have generated our 25.175 megahertz clock. Okay, so I think that's about it for this. So we can now go on and create our sync pulse like we were doing. Okay, like we wanted to create a little earlier. So this process is sensitive to the clock, to our sync clock, because that's what it is checking. And things happen on the rising edge, well, I can rising edge of clock or falling edge. So on rising edge of sync clock, EDGE, yes, I can type, sync CLK. Okay, then when we're on the rising edge of clock, and if, so that we can be sure of everything going on. So on the rising edge of clock, what we want to do is that at this point, I am going to need to do two things here. One, I'm going to create my sync pulse, and I also need to also create the counter. I mean, I declared these two signals, H pulse. I created two signals, H pulse and V pulse, but I have not actually made them counters yet. They are not counting through anything right now. So I'm going to need them to count, and I'm also going to need to create my sync pulses. So let's create the counters here. Since this is, I'm working on rising edge, let's create the counter. So if my H position is greater than or equal to the sum of everything that we have here. I already have these ones here. Let me just pick them. What I have missing from them is what? What is missing? HVA for the viewing area. So if it is greater than or equal to the sum of all of these, then I want to reset my H position. H position. I'm going to reset that to 0. So once it goes greater than that, I'm going to reset that to 0. Otherwise, my H position will simply be equal to H underscore position plus 1. Okay, so it's just simply going to be equal to that. And so that's about that for that. But then I also need to do the same for my V position. Okay, I'm going to do the same thing for V position. Now I'm going to check whether V position is greater than this, and if not, if yes, then I'm going to reset it. But when do I want to reset it? When do I want to reset it? When we want to reset my V position is when we get to the bottom right. In other words, your H position will be this, and your V position will also be that. So when your H position is this, I will go ahead and check my V position as well. I'm just going to copy this to save some typing. So I'm going to check that if my V position also is greater than this, then I forgot the then here. So when my H position is greater than that, then I'm going to go at, has gone beyond the total number of columns I have on that row. Then I'm going to check my vertical position and see whether it has gone beyond. If it has gone beyond, then I'm going to reset my V position as well. So I reset my H position already. I'm now going to reset my V position as well. Otherwise, if I've gotten to the end of the row, but I have not gotten to the end of all the rows, then I want to increment my V position. V position plus 1. Okay, and end my if here. So I'm just going to recap that. When I get to the end of any row, I reset my H position. But when I'm doing that, I also check whether I have gotten to the end of all the rows. If I've gotten to the end of all the rows, I reset my V position. Otherwise, I increment my V position. So I've finished one row, so I'm incrementing to the next row. Otherwise, I go back to the very top if I've gotten to the end of all the rows. If I have not gotten to the end, if there's a rising edge of the clock and I have not gotten to the end of any row, then I just increment my position on that row. I hope that is clear. So that's it for the counters. I've created my counters. Last thing I need to do is to create my sync poles, and we're just about done with this. So for this, I don't need the rising edge of the clock. I'm just going to check my H position. If my H position is greater than, if my position is, I've gone past my front porch. So if my H position is greater than the front porch, do I want to use greater than or equal to? I started from 0, so greater than or equal to. If it's greater than or equal to my front porch, and my H position is less than, this should be less than, it's less than my front porch plus my sync poles. If it is, in other words, if it is greater than, if I've gone past my, maybe I should pull this up and talk using this diagram. Where is it? Here. So if I've gone past my front porch, and so 0 is where front porch will start. If I've gone past my front porch and I have not gone past this point, so it is greater than or equal to front porch, but less than front porch plus sync poles. If that is the case, then I'm going to make my H sync. I'm going to assign H to my 0 to my H sync. Otherwise, I'm going to make my H sync 1. Just going to repeat this code for my V position, and I am done. Okay, so that's that, and put this here for V sync, V position, V front porch, V position, V front porch, V sync poles, and that's about it. So that's it for this code. I'll hit compile, then I'll take a look at the code once again to see that I have actually done everything I should do. So just looking through, hopefully there will be no error in this, and I hope it actually does go through for the first time in my life. Well, not first time in my life, but yeah, first time writing the code first time and having it go all the way through. Okay, so not surprisingly, there is an error somewhere. Where is this? Line 26. It is expecting, okay, so it says this here. I should have made that a comma, not a semicolon in the port mapping, so that's what I complained about. Once again, looking through, I think this is about everything I should do in here. Okay, another. Oh, okay, so it's complaining about this rendition, how I am putting this here. So now I need to confirm, okay, I think it is just an X, there's no 0 there. Yeah, I think that should be correct. I think there is no 0 in front of it. Apologies for that. 0x is when we're writing it out, or when we're writing it, I think in C, when we write the code in C. When we're writing the code in VHDL, it's not 0x, you just put an X in front and it knows that it's a hexadecimal that follows. Explaining, I did not end my case. Apologies, end case. Okay, so end case, let's go ahead, compile once again. And I think that should be about it. It should run through this time. I don't think, and if I did not end an if here, and if this is ended here, this is begun, this is ended here, this is ended here, this is ended, that is ended. Okay, what's the error it complained about? H-sync expecting it then. Yes, I did not put it then here. Then, not put it then here. Okay, so this should be done. This should be good now. Okay, it's just waiting for it to run through. Once again, what's it? H-sync is used but never declared. What did I call it here? Oh, I did not use, okay, so I'm going to put an underscore here because I think that might be easier than changing the code in all the way down. So I think that should be about it. And no, this will cause a problem. So I think, so I've created my QSF file already. I took the liberty of creating QSF file before, making the video so that, oh, I put the underscore there. Yeah, so apparently I'm used to using underscore, but I didn't do so when creating the entity declaration itself. Okay, so that will be this, and we're going to program this onto the board. I want to program it onto the board. You should will connect this up to a display, and I'll pull up a camera so you see how this looks on the display, on an actual physical display. Okay, so it is done programming, and next I will go ahead to program the board. But before doing that, let me pull up my camera. Okay, so the camera is up, and I'll go ahead and program the board now. So I'm going to click on Start Programming. Okay, so I'll focus this on the screen. Well, to try to get the FPGA and the screen at the same time. So I'll start now. Once it's done programming, now we see the display. And on the display, you just have, like we said, you're going to have between, I think it's positions 50 and, what are the values we set? I think this was 120 and 300, if I remember well. So think about the total number of rows is 480. So the total number of columns is 480. Okay, sorry, my son is trying to get in on the action as well. So the total number of rows is 480. Total number of columns is 640. So I think this is between 50 and 100. And if you think about that, this is maybe about a sixth of the screen. So that looks quite valid. And then that's between 120 and 300. Now go ahead and flip the switch. If I can get both. So I'm going to flip the switch. I want to flip the switch. The display should change. Flipping 1, 2, 3, flip. And the screen changes 1, 2, 3, flip. 1, 2, 3, flip. Okay. So this shows that the program actually is doing what we expect it to do. Okay, so what we expect it to do. So that is just a simple presentation, and yes, not much seems to be happening in this code. I mean, really all it does is draw a box on the screen. You can imagine using an equation of a circle. You can imagine using an equation of a circle to determine what, I say for instance, a circle showing up on the screen. Okay, just trying to move it to another angle to see if you could get a true color that I can see without any of the glare, but that is a little difficult to do. Okay, so one could decide to draw a circle somewhere, could decide to draw a square. It's also possible to take out data from memory and display it onto the screen. Okay, so we could decide to take data from a memory file and display that on the screen, or take numbers, take letters, take alphabets, and display them on the screen. That'll be a subject of a different video, but for now, this is a simple way we can display things on a video screen using VHDL. That's it for this video, and that's it for this video series. Thank you very much for watching it, and hope you have a good one. See you in the next video.